In our last example, we were talking about this idea of a car trip and figuring out our speed. And we use, for a graph with time and distance instead of x and y. All right. Well, now we're going to talk about what if we switch to x and y, or a normal coordinate system that you see in mathematics. How does that change what we were doing? Well, before we were talking about speed, okay? And the reason we talked about speed is because it's a really good example of a rate that you're used to seeing and talking about. We also talked about how, we talked about another rate. We talked about the slope, right? And we said that the slope is an example of a rate, and that when we look in a graph and we figure out the slope or the rate, if it's in terms of time and distance, we call that rate speed. So I want to bring it back and remind you that even though we've been talking about speed, what we've really been focusing on is the rate and the slope of the function. So let's look at a function, and I'm going to pick a nice friendly one. We're going to talk about f of x equals x squared. And we're going to go ahead and graph it. Okay. Now, remember from last time, the big question we had was, right, if we had 2 points, we knew how to figure out the slope or the rate between them. But what if we only have 1 point, and I want to figure out the rate at that single point? How am I going to do that? Well, what I'm going to suggest is kind of to be a little clever, that maybe we can't find it at that exact spot, but we can figure out something pretty close to that. So what we could do is we could pick another point somewhere on the graph, and we could find the slope between those points. It may not be exactly the same as at the red point, but it should be similar. Right? Well, that's not bad, but is it good? How do we figure that out? Well, what if we picked another point right here, and I drew it, the line, or this between them? Well, if we look, the slope of these lines are very different. How do we know which one's a good estimate and which one's a bad estimate? Well, usually the way I think of it is what we want to do is try to make it so that the line is as close as possible to the slope at that point. So if we were to draw, like, imagine almost like zooming in and looking on either side of that point. If you zoomed in, you would see something that looked almost straight. That almost straight line, its slope is going to be the same or about the same as at this point. So if you can kind of imagine, right, this line that goes right next to the curve, and now I'm going to extend it out, what we would see is that right there next to the curve, that these two, their slopes are almost identical. And so this green line is actually a really good estimate of what a line with the same slope as that point is going to have. Right. So what I want to do is draw another graph, and we're going to try to do the same thing. We're going to try to estimate what the slope at that one single point is. All right, so here we have another curve, and let's say this is the point that we're interested in, right here. Okay, so I'm going to focus in really close on either side of it. And what we're going to do is try to draw a line with almost the exact same slope as the curve right in between there. Okay, so we're going to draw right in between and keep going. this line right here, this green one, is a really good estimation of what a line with the same slope at that point is going to have. And the nice thing is if we actually have more information, if we could figure out some of these points, you could actually find the slope here, and you'd have a really good guess or estimation of the rate at that red point.